This is the second benchmark, which covers Unit 4 through Unit 6. This is specifically Unit 4. Now, our first question asks us which equation best represents the graph. Now, when we're going to do that, we're going to do equations in slope-intercept form, which looks like this. Y equals, where m is the slope, and the last number is the y-intercept. Now, I've gone ahead and circled the y-intercept on the graph for this question, and you can see that it goes through +1, +2. Now, when you look at the answers for this one, well, neither of these go through +2, which only actually leaves our last answer. Now, as I was about to start doing this video, I noticed there's actually a problem with this question. D is actually the wrong answer, although it's the only one that goes through +2 on the y-axis. And this does not have a slope of +3. This is actually going downwards, so this should actually say -3 for this one here. Now, the reason it's -3 is, if we do our rise over run calculations, I can see this goes down 1, 2, 3, 4, 5, 6 squares, and then across 2 squares. So if I do my rise over run, as we go down I give it a negative sign, so I went down 6 squares, across 2 squares, and then if I work that out, it's -3. So the answer to this equation should be y equals -3x plus 2. Plus 2 again, because it went through 2 on the y-axis. So actually there is a problem with this question. Next question, what is the correct slope and y-intercept to the equation y equals 5x? Well, we're going to use that same idea. We're going to use this y equals mx plus b, and notice that the x number for this one is 5, so that means that the slope must be 5. And that actually only leaves us with a couple of answers. I can get rid of answer A, and I can get rid of answer B straight away. Now, there is no number on the end, so it might be tempting to say that it doesn't have a y-intercept. Just for convenience sake though, when we have 5x plus 0, we just say that it's 5x using the additive identity property. So actually the answer to question 2 is a slope of 5 with a y-intercept of 0. Also, this comes back in chapter 5 when we talk about direct variation as well. One of the properties is a straight line going through 0, 0. And you can easily identify it goes through 0, 0, is that there's only one term, there's no y-intercept. Question 3. Which inequality best represents the graph you can see? Now, all the inequalities on the right are all exactly the same here, -3x minus 2. So we know that that's what the equation of this line is. You can actually see it has an intercept of -3. If I was to add a couple of points to this line, I go down 3, across 1, which is why this has a slope of -3. So we've got to do a little bit more work. We've got to try and narrow this down a little bit. Now, I notice on inequalities there's two types of lines we can have, a solid line or a dotted line. This is clearly a solid line, so I'm looking for the inequalities that have a solid line underneath the inequality, which means I can get rid of these two options here. And now I've got to figure out which side of the line is actually shaded. So if I take a point on the line, I can see that I'm going lower than the line, which is less than. So the inequality that's less than for this one would be D. Now, I should probably check to see if this is actually correct. So, on my graphing calculator, I'm going to go to graph. And at the moment it says y equals, but I want it to say y is less than or equal to. So I'm going to change the type of graph. I don't see the option I want, so I'm going to press F6. And now I do see the option I want, less than or equal to. And it changes it for me at the top. And now I can go ahead and type in -3x minus 2. And then when I press draw, I can see that the graph does indeed seem to be very close to the picture that we have on here. So I'm thinking that's probably a good answer for this question. Question 4. Which equation best represents the graph? So we want to use the same idea that we used before. Let's look for the y-intercept first. So -3. So anything that doesn't have a y-intercept of -3, I can actually get rid of straight away. And then now I can do my slope calculation. So it goes up 1, 2, 3, 4 squares, and then across 2 squares. So rise over run, 4 over 2 equals 2. So the slope is 2, therefore the equation is y equals 2x minus 3. Now I can also check this one on the calculator as well. If I go back to here, if I get rid of this equation, now it still says y is less than or equal to at the top. I'm going to change it to y equals, but sometimes it doesn't always work, even though it appears to there. So I think it's 2x minus 3. So I'm going to check. That indeed does look very close to that picture. For example, if I was to try D, which is the other option, I'm going to put the 1/2 in parentheses just to try and make sure I don't make any careless mistakes. 1/2 x minus 3, and then try drawing that one. You can see that the y-x-intercept is at a totally different place here. 1, 2, 3, 4, 5, 6, whereas it's clearly not 6 squares across an hour. You can also see the slope looks totally different, but sometimes that's just because the scale of the window, so it's good to check exactly where it crosses through the axes. Question 5. What is the slope of the line 2y equals 4x plus 6? One good answer straight away is 4, because it looks like the number of x's, and we already said the number of x's is the slope. That's true, providing it's in slope-intercept form. This one is not in slope-intercept form, because it starts with 2y and not just y. If we divide everything by 2, then it will be in slope-intercept form, and then the question is as easy as just looking for what is the number of x's. So make sure you put it in slope-intercept form if you're trying to find the slope. What is the slope of the line through these 2 points? So we need a key formula for this question. y2 minus y1 over x2 minus x1. So this is our first coordinate. This is our second coordinate. Remember, x comes before y as well while we're doing this. So y2 for this question is 18. y1 for this question is 9. x2 is negative 3. And x1 is 1. So on our calculators we can then work out what these are. So 18 take away 9 is 9. And I'm almost confident straight away what this is going to be. This one doesn't seem to have any of those numbers. It looks like it's going to be this one. It might be something that simplifies though, so we should carry on just to make sure. Negative 3 take away 1 is negative 4. And if you have a positive divided by a negative, it becomes a negative. So that is indeed the correct answer. It's going to be C. Now we can also check these on the calculator as well. If we go into stat, type in the 2 coordinates, 1, 9, and the other coordinate is negative 3, 18. And then I press graph just to make sure I can see both of the lines. I can certainly see this is a negative slope, although that doesn't narrow down any answers for this question. Calculate, and your box will actually be lit up for x for these questions when we do that. And it tells us the slope is y equals ax plus b, where a is the slope, and it tells us that a is negative 2.25. Now, unfortunately, it does give it to us as a decimal, not as a fraction, but we should be able to change that back as well on the calculator if we go to run. So if I type in negative 2.25, press enter, then press the fraction to decimal button, it will go ahead and change it for us. So we can see that it is indeed negative 9 over 4. Another way of checking which one it is you can just enter each fraction individually. Negative 2 divided by 27, and check, do the decimals match up. So I'm going to go straight to the last one, or straight to the correct one. Negative 9 divided by 4 is negative 2.25, which is what we had. So we know that that is the correct answer for this one. Okay, question 7. Slope of a horizontal line. If we know Mr. Slope Guy, which is something that we looked at in this unit, then actually we can figure this one out pretty quickly. So the horizontal line is the one that goes across like this, and if we look at the end of his mouth we can see his dimples, which is 0. The answer for that question therefore would be 0. Just a reminder how the rest of Mr. Slope Guy works. You have a vertical line, you can see the U here, which would be the answer undefined because it begins with U. And a reminder that positive slopes go this way and negative slopes go that way. So that's something that you should also be using when you're trying to do this benchmark. Last question. We have another slope question. We can try and enter this one on the calculator, but this one's actually not going to work. So just to show you why that's not going to work, 4 and negative 3, and 4 and 3. And then when I press my options again, graph 1, it says error for this question. So when we get an error, it's one of two things. It's either going to be 0 or it's going to be undefined, and we have to figure out which one it is. So we've got to resort to something slightly different. What we could do is we could plot these 2 points and probably figure out which is the correct answer. So 4 negative 3 means you go across 4, and then you go down 3. 4 3 means you go across 4, and you go up 3. And you can see quite clearly from this one, this is a vertical line. If we go back to Mr. Slope Guy, the vertical line is the U, which is undefined. Therefore, the answer to this question is undefined. So the stat method works for most questions. If it doesn't work, it's either 0 undefined, and then you've actually got to check. The ones where it won't work is when either the first coordinate, which is what happens here, are the same, or if the second coordinates are the same. And that concludes the benchmark review for Unit 4.